Mr. Armstrong. Hello, my name is Renata and welcome to the STEAM Expo. We are the robotic arm team presenting Mr. Armstrong, a robotic arm for our final project with our robotic class. So what is a robotic arm? A robotic arm is a programmable mechanical device that mimics the function of a human arm, using a series of links, segments, and joints for a variety of tasks that require speed, precision, and consistency, all to maneuver the end of the arm, also referred to as the end effector. The first robotic arm was invented. The first robotic arm was invented. The first robotic arm was invented in 1959 by George Devil and Joseph Engelberger, and they call it Unimated. It was used for automated discussing with the General Motors plant factory. Since then, robotic arms have made significant. The first robotic The first robotic arm was invented in 1959 by George Devil and Joseph Engelberger, and they call it Unimated. It was used for automated discussing with the General Motors plant factory. Since then, robotic arms have made significant advances with expanded industries with milestones like the Stanford arm, the Puma arm, and the Da Vinci surgical system. The impacts changed the way we advance with the medical field, manufacturing, safety, and of course, engineering. And with the impact of AI technology, we can only see the impact of robotic arm growing as programs are created to learn and adapt. This has inspired our build and story for the final project for our class. Introductions to coding, robotic, electronics, and technology, and build a robotic arm. The Armstrong is made up of two DC motors, two microbits, and the servo motor, housed between different 3D prints and held together with a lot of glue. One thing we could have done differently was that the team constantly struggled with gravity in designs with a very high center of gravity, which required the late addition of counterweights and adjustments to the motor speed. I believe we should have done the mass and balance calculations in the initial designs phase in SolidWorks instead of treating them as a post-printing problem.
My name is Jack, and I will be breaking down how exactly we built our robotic arm using SolidWorks and the problems we faced working with this medium, and how we adjusted. I went into this assignment not knowing much about SolidWorks, but watching a couple videos on the subject made me learn quickly. To build the arm, we constructed a large hollow cylinder to hold our DC motor, along with a hole in the side for our wires to reach our microbit controllers. Our DC motor rotated the base 180 degrees, and the arm was made from 3D printed plastic. The claw was the hardest part to design. My first design was too big to fit onto the arm, and the pieces I built wouldn't fit together. I printed separate parts to fit together. Kevin printed his own claw and included a piece to fit a servo motor to open and close the claw. In terms of what I would have changed, I would have added a second servo motor to move the claw up and down. It was a lot easier to move the arm up and down without adding anything extra.
My name is Kevin, and I will be discussing the programming behind our robotic arms movements, any problems we faced, working within the coding, and how we've adjusted. We created our code using Python on a microbit website, a programming we have been becoming increasingly familiar with this all semester. First, we needed to decide on what we actually wanted the robotic arm to do for its action. And based on its movements, we were able to reference code we learned earlier in the year. We started off by programming the arm to tilt down when it was physically gestured down by the controller using the accelerometer feature within the microbit. We initially had trouble with making the accelerometer move the two motors that we had connected. We also needed to control a servo using a button that opens and closes the robotic claw. The servo was controlled on a different microbit for simplicity. One problem we had was the gravity of the arm rotating the motor down. We had to code in the motor to consistently fight gravity. We had to change speeds because each rotation had different forces on it. For example, the arm, we had to apply more force going up than going down. Another issue that we are currently having issues with is the servo not working unless it's connected to a computer. The outside power that is connected to the microbit is not allowing it to work with our code, and therefore we have to use a computer to make it work.
One thing that we would have done differently with this project is wiring. Spending more time with cable labeling and management would have decreased time spent disassembling and assembling parts while troubleshooting. Another thing that we learned from this project that we may use in other projects is applying more notes in our program. Many times we got lost trying to troubleshoot errors or change parts of code. Notes would have helped us find or add code.
My name is Nikita Harper, and I will be closing this project out with an overview of what we've learned, what we would have done differently if we were to do this again, as well as how the class has changed our view on robotics and coding. Throughout this course, we have gained new skills and learned the look of a life of an engineer. From the late nights to the frustration behind coding with bugs, all the way to the elation from when you finally comprehend a concept and find yourself subconsciously applying concepts you've learned in class to your everyday life. Engineering is everywhere you look, and the science and minds behind the stories are determined and encouraging, ready to change the world for the better in their own ways, and this is one of the ways that we've done it. This class has taught us that anyone can be an engineer because no one knows what they're doing, but we don't let that discourage us. As a result from this class and project, we've each learned a myriad of skill sets, from becoming accomplished coders to interpersonal skills from working in a good team, all the way to our work ethic itself and having a degree that builds it all. And based on what we've learned so far, we each hope to continue to improve on the challenges and roadblocks we've faced, from motors overheating to cable mismanagement. And based on our final, we have a long way to go, but we'll work to encourage each other along the way. As our winter semester closes, we each hope to continue to be able to showcase the accumulation of an entire semester's worth of coding and robotics as the start or in addition to our engineering portfolios. As we use this winter break to create independent projects that have piqued our interest based on the knowledge we have accumulated within these last months of 2025, and come back for the spring semester of 2026 ready to do it all over again. Thank you to Professor Vincent for teaching us in such a tactile manner, as well as to our TA Nick for always being ready with a guided solution, and to all of our classmates who have helped each other with many, many questions asked. See you on the front lines. Thank you for your time. We are the Weak Legs.